In this video, we're going to show you how to take the Lioness that was created in the modelling tutorial for this example and calculate 3D roughing, finishing and a 2D cutout toolpath to machine the part. I'm going to use a variety of techniques here, including multiple roughing toolpaths, and also show you how you can evaluate the preview to make sure that the tool you're using at different stages is appropriate. Let's open a copy of the software. So let's click on the icon to open an existing file, and from the project folder I'm going to select the file lioness_model.crv3d and hit open. Now there we can see the 2D view. I'd like to see the 3D view as well, so I'm just going to click on the icon here to tile the windows so that the 2D view is on the left and the 3D view is on the right. And before we go over and start calculating the toolpaths to machine this, I should check the size is the correct dimensions for the part that I actually want to cut. Let's come down and click on the modelling tab, and I'm going to select the component that we're going to cut here. And if we come up and click on the icon to set selected object size, then that's going to show me its width and height, and if I wanted to I could adjust these now. I'm happy with the values that we've got there, so I can hit close. Next I want to check the height of the model in Z, so I can come up and click on the icon here to scale Z height of model. This is going to show me its current height here, and if I want I can adjust this either using the slider, a percentage value, or I can click on the button to set exact height. Now I'm planning to cut this out of a 1/2 inch block of material, so I want to make sure that it's somewhat smaller than that to allow a little bit of space above the model, and also to allow a little bit of stock on the back of the part as well to make sure it's thick enough. So I'm going to scale this down to be 3/8 of an inch and hit apply and close, and all I want to do is just make sure that that still looks okay and I've still got the detail and depth that I'm hoping for in the part that I want to cut. If I'm happy with that, we can go ahead and hit OK. And at this point I'm ready to go over and start calculating toolpaths, so we can come up, click on the icon here to switch to the Toolpaths tab. What you'll see happen there is the modelling tab or the design tabs will close on the left and the Toolpaths tab will open over here on the right. Next we can click on the set button under material setup here. Now if you do plan to actually cut this part, you should make sure that you recalculate all the toolpaths using parameters and settings that are safe and appropriate for your particular machine, the tooling that you have available and the material you're planning to use to cut it in. Here, as I said, what I'm going to do is use a piece of material 1/2 inch thick. We'll work with Z0 off the top of the block, which is already selected, and the XY datum or the XY00 position in the lower left hand corner of the model. And you can see that displayed in the 2D view by this red square, and in the 3D view by the gnomon or the arrow indicators showing us the XYZ home position. Next we want to adjust the model position in the material. You can see at the moment this is pushed all the way to the top of the material. Typically when you're cutting a 3D part like this, you'd like to leave a small gap above the model to ensure that there's a bit of space to allow for any inconsistencies in your material thickness or when setting the Z0. So in this case, let's just enter a value of 0.025 of an inch, so we have a small space above, and that means that we're going to have 0.1 of an inch of material below our model there. So that's just going to be additional stock on the back of the part to add strength. Rapid Z-gaps are appropriate here for the tool to lift out and move to other positions in the toolpath, and the home position is okay. We can maybe move that down a little if we want there, and once we're happy with that we can go ahead and hit OK. Now for this particular part I'd like to show a technique where we actually use 2 roughing passes to hog out the majority of the material before we go ahead and create the finishing and the cutout toolpath. The first roughing pass is going to be a Z-level cut, which is going to really clear out in 2D toolpaths the majority of the area around the part. Then we'll do what we call a raster roughing, which will take us much closer to the finished surface, and that will allow us to have much less loading on the finishing tool, and so hopefully run that a little bit quicker. It's not essential to do this 2-stage process, but it can be quite a useful technique for certain fairly low-level sort of organic models like the one we've got here. So we'll come up and click on the icon for the 3D roughing toolpath, and in here I want to select a 1/4 inch end mill in this case, so we'll choose that tool there, 0.25 inch end mill. I'm just going to take the default settings for this and hit OK. In this case we want to use the model boundary, so that's just going to pick up the visible model from the 3D view and use a boundary around that 3D object there, so I don't need to have any vector selected when I choose that option. And I want to come past the edge of that boundary to make sure the tool clears material right the way down to the modelling plane, so that we've got a nice clean edge that we can come in and cut out around. So in this case we'll use quite a large boundary offset. We'll go 0.25 of an inch, so that means it's just going to extend the toolpath 1/4 of an inch past the edge of the model. The machining allowance for the roughing allows us to add a sort of an imaginary 3D thickness on our model. What that's going to do is keep the roughing tool a little bit away from the finished surface. That ensures we've got some material to cut with the finishing tool, but also minimises the chance of the roughing tool creating some tear out or chipping our finished surface. As I say, for the first roughing strategy I want to use Z-level roughing in this case, so that's effectively 2D machining around the 3D object. And I'm just going to come down and we'll call this toolpath 3D roughing Z-level and hit calculate. Now we can see the software's automatically opened the preview toolpaths form here. We can just click and rotate this and you can see we've got a couple of two-dimensional toolpaths cutting around the 3D object there. So let's take a look at those in the preview. We'll click on preview selected toolpath. There's the tool just machining out around there. Maybe we'll just zoom in a little and you can see how that's cutting these 2D surfaces. Now in a lot of cases and for a lot of material that's fine and we could now proceed on to the finishing toolpath, but in some cases we'd like to get a little bit closer to the finished surface, and that's where it may benefit us to use a second roughing toolpath using the raster option. So let's just return this so that we've got the split screen. We'll go to View, Tile Windows Vertical again. Let's close the preview toolpaths form and let's go back up to the roughing toolpath again. I'm going to use the same tool this time, but I do want to change the parameters a little. The way the raster works, it'll create a 3D toolpath over the part, but it will recut the same areas if the pass depth on the tool is shallower than the model. In this case, because we've already used the Z-level roughing to clear it out, I can do it effectively in a single pass. So if we click on edit here, for the purposes of this toolpath only, I'm going to override the pass depth of the tool. I'm going to set it much deeper than I would normally for a tool like this, and we'll set it to 1/2 inch and hit OK. I'm going to retain the model boundary setting and the allowance setting and just change this to 3D raster, and we'll change the name so we can differentiate that and call that 3D roughing raster and hit calculate. Now by entering that 1/2 inch pass depth in here, what I've allowed the software to do is cut over the surface of the model in a single pass, as you can see here, and that's fine because I'm going to have already cleared out the material using the Z-level roughing. So with that selected, I'm going to preview the selected toolpath and you can see the effect that that's going to have on the finished part. So now we've really done a good job of clearing out the material over the 3D object. Just hit close on the preview toolpath form and come up and click on the icon to create a 3D finishing toolpath. Now here I'm going to hit select, and from the tool database I'm going to choose a 1/8 inch ball nose tool. We can just adjust the settings if we want there. Very important when doing finishing is the step over. That's the distance between each pass. The smaller this value, the better finish I'm going to get on the job, but the longer the part will take to cut. Typically for a nice clean step over, you're going to go somewhere between 8 and 10% of the tool diameter. So let's set this down to 8% here. We'll hit apply and OK. We're going to use the model boundary again in this case, and this time for the finishing I don't need to come as far past the edge, so I'm just going to set a value 0.1 of an inch. I'm going to raster over the job, raster angle 0, which means the passes will be parallel to the x-axis. I could change this, put in say 90 degrees if I wanted them to be parallel to the y-axis, or anything in between 0 and 360. In this case we'll just leave that at 0, we'll put in name of 3D finish and hit calculate. So there's our finishing toolpath. Again, we can preview the selected toolpath, and the software is just going to run our 1/8 inch ball nose tool over the job there and show us exactly what the part will look like after we've run both our roughing passes and the finish. At this stage, it's important to take a look and make sure that this is giving you the detail that you'd expect. If it's not getting into the smaller areas of the job, then you may need to change to a smaller tool. Also, if you're getting a sort of rough looking surface finish, you may need to reduce the step over of the tool as well. This stage, I'm pretty happy with the way that looks. I'm just going to go back up to View, Tile Windows Vertical so I can see the 2D and 3D view. We'll close the Preview Toolpaths form. The final thing I need to do is cut the part out. Now, to do a 2D toolpath like the cutout profile, I need to have a vector for the tool to follow. I don't have the option to select the model boundary. So we're going to need to come over to the 2D view and just make sure we've got a vector that represents the edge of our part. Let's go ahead and just maximize the 2D view, and clicking in the 2D view there, I'm going to hit F to fit that to the screen, and then we'll click on the icon here to switch back to the drawing tab. Now if we come on to the layers, you can see that I've got a selection of layers from the original drawing of this part, and if I switch those on, I have actually got a variety of vectors in the background there. It's a little difficult to see because the grayscale for this layer is on the last layer in the list. So what we may want to do is just select that grayscale there, right mouse click, move that to a new layer that I'll call grayscale, and we'll just make that invisible and inactive, so we remove that from our 2D view. And you can see there that there is a layer that's been created that I could switch on and off at any time. Now in this case though, what I would like to do is get a set of vectors that represent the outside edge of my part. Now I can see I do have those, but it's made up of a number of separate vectors at this point in time. So what I'm going to do is just select those by holding down the Shift key on the keyboard and clicking the mouse to select the vectors that represent the outermost edge of my part. So there should be 5 of those there: the tail, the legs, body and head. I'm going to right mouse click, copy to layer, new layer, and we'll call that Cutout, and we'll make that visible and active and hit OK. So I've got a copy of those vectors on this new layer. I'm just going to undraw the other layers here by toggling the light bulb and make sure the cutout layer is selected and is current. There, just by clicking in the background, I've gone back to the drawing tab, and now with all those vectors selected, I can come over and click on the icon here to weld selected vectors. What that's going to do is just take the outermost area of each of those and create the union of them so that I end up with the overall shape. Now we can come over, click on the icon to switch back to the Toolpaths tab. I can select this vector here, and with that selected we can create our profile toolpath. So I'm going to click on the icon for that there. I want to cut all the way through my material, so I'm going to type Z equals to pick up the thickness of the block there. You can see when I hit the equals key, it's just filled that information in for me. Now for this job, I only need a simple version of the profiling toolpath, so I can uncheck the box for Show Advanced Toolpath Options and work with a shorter version of the form. I'm going to click on the Select button. I'm going to choose a 1/4 inch end mill here and go ahead and hit OK. And if I want to, I could hit Edit and just check the parameters for that. So in this case, maybe I'm going to go ahead and aim to cut this out in 2 passes. So we'll go with a pass depth of 0.25 of an inch and hit OK. I'm going to cut outside the part here. I could ramp if I want to. In this case, I'm not going to worry about that, but I do want to make sure this Add Tabs to Toolpath option is checked here. And for that, I'm going to set a toolpath length of 0.3 of an inch, thickness of 0.15, click on the Edit Tabs button. Now I could add the tabs by specifying numbers or values in here, or I can just come over to the 2D view while I'm in the Toolpaths tabs form and click areas on the vector where I would like to add a tab to hold the part. So I'm going to do that at the end of the tail here because I think that may be a little weak. Do that on the leg here, and then on the back there, and hopefully that'll be enough. Let's hit close, call this profile cutout, calculate, and there we can see how the part is going to be cut out using that particular tool. Now I can already see that there's kind of an area here where that tool doesn't appear that it's going to be able to fit through. If we want, we can preview the selected toolpath and check that, and I can actually see that that is the case. That tool is too large to fit between the chin and the leg. So if I do want to cut that out using the tool, I will need to go to a smaller size tool to do that. So in this case, let's click undo last so we can go back a step in the preview. Let's go ahead and close the preview, double click on the profile cutout, and let's hit select and change the tool. Now at the moment I don't have a smaller tool than that specified, so I'm going to select the end mill here. I'm going to say copy, then I'm going to select the top one in the list, and I'm just going to edit the values in this so that it becomes a smaller tool. Now in this case, let's go down maybe to a tool that's 1/8 of an inch in diameter, so I'm going to put in an end mill, name 0.125. Also very important to remember to change the actual diameter of the tool as well. The software will give you a warning if you forget to do that, but it's just good practice to check the name and the diameter match. If I'm happy with all the other settings, I can hit apply and OK, and with the same parameters there, I'm just going to go ahead and hit calculate. Visually I can already see that the tool is able to get in and around there now, but if we click preview selected toolpath we can check that for sure. And I should be careful with the small piece of material there, that if I think that might cause damage as it's cut out, I may want to add a tab to hold that in place, or I may want to pocket that down first. In this case I think that'll probably be small enough not to cause a problem to my tool or to my dust collection system. If the preview at this point looks right, then I can go ahead and save these toolpaths, so we can close the preview toolpaths form. In this case I have these two different roughing toolpaths I've calculated, but I would like to output them as a single file. To do that I would just check the two boxes next to those, click on the Save Toolpaths button, and then make sure the box at the top here that says Output all visible toolpaths to one file is checked, and there we can see those two toolpaths listed. I can choose my appropriate post-processor for my machine from the list and click on the Save Toolpaths button, give that a name, and the software will save that as a single file that I can run on the machine. Then to output the other toolpaths I would just select them from the list, uncheck the output visible toolpaths to one file, make sure I've got the correct toolpath in the list there, and again hit save, save my finishing and save my cutout toolpath. Let's go ahead and hit close. So at this stage we can save the file here so that you can see a copy of this. Let's go up to File, Save As, and in the project folder I'm just going to save this file, call it Lioness Toolpath, and as I say, if you wanted to you could open that and see it in exactly the state we've created in the video. And at this stage that concludes this particular tutorial.